Hi everyone, in this video I'm going to talk about functional dependencies. They are very important. This is a very important concept in database normalization. Functional dependencies describe relationships between attributes, and we need to determine functional dependencies to determine keys of a table or of a relationship when we're actually decomposing relations. The definition says A and B attributes are attributes of a relation R, and B functionally depends on A if each value of A is associated with exactly one value of B. Now let's look at the staff table here. We have attribute staff number, staff name, and you can see that staff name functionally depends on staff number, which we can denote using an arrow from staff number pointing to staff name. Now, how come? Because for each value of staff number, right, each value which is SL21, SG37, SG14, etc., there's only one value of staff name. So it's a one-on-one relationship here. For each value of staff number, there's only one staff name. Now, this wouldn't hold if there was, let's say, another SL21 down here, and then it points to a different name, then it would not hold. But it's not the case. So I'm just giving this example so you can imagine when would it not hold. For example, let's say we have SL21, and then Mike something, it became Mike, right? Mike something, then this will not hold. But since there's no such data, we know that it holds. On the other hand, let's see position and staff number. So for each staff number, there's only one position value. Now some of you may say, oh, but there's two managers. But again, go back to the definition. For each value of A, so the keyword is each value, is associated with exactly one value of B in relation R. So for each value of A, again, I'm repeating, but this is a mistake students do frequently. There is only one value. For SL21, there is manager, right? But here it's SG5 and manager, not SL21 and something else, okay? SG37, there's only one SG37, and it's first of all, if you see all the rows are unique, then you're halfway there. You can tell that there's not going to be another value with the same value for that row, and it cannot have a different position because all the rows here are pretty much unique, right? Now, for staff number, position functionally depends on staff number, but the reverse does not work because for manager you have SL21, and for this manager you have SG5, so it does not fit the description. So the reverse does not hold. Okay, that's the case. Now you can also combine attributes on a functional dependency. So this is how the functional dependency is denoted. You have the determinant on the left side, and then it points an arrow to the determined attribute, right? Now the characteristics. Determinants should have the minimal number of attributes necessary to maintain the functional dependency. Then it's called full functional dependency. So full functional dependency is an important concept because if you don't have full functional dependency when you're designing your tables, if you cannot reach it, if you have partial dependencies or transitive dependencies, then your table is exposed to update anomalies. So in order to get rid of those, you have to have full functional dependency. So B depends on A is a full functional dependency if removal of any attribute from A results in a dependency no existing. But partial functional dependency, if some of the attribute that can be removed from A, then the dependency still holds. For example, let's say we have a relationship A, B, C, D, let's say E, right? And then we have these dependencies. Let's say A holds C, D. So if C and D functionally depend on A, and let's say E functionally depends on B, right? So we need a key to be able to uniquely determine each row, right? So based on these functional dependencies, we can suggest the key can be AB, because when you have AB, first you can determine A from A, right? Then B from B. Then you have C and D coming from A, and then E coming from B. Now that's great, but the problem here is that we don't have full functional dependency because C and D, they are determined by A and E is determined by B. So this is a partial dependency. So this is what partial dependency is. Okay. On the other hand, transitional dependency. Let's create another relation. Let's say this one is JK L M, and then we have actually, yeah, let's say K and L depends on J, then M, and then L depends, so M depends on L, and then let's say M also depends on J. So this transitive dependency, right? So you have M can be functionally determined by L, and then L can be determined by J. So this is transitive dependency. Transitive dependency describes a condition where A, B, C attributes of a relation such that if B depends on A and C depends on B, then C depends on A. C is transitively dependent on A via B, provided that A is not functionally dependent on B or C. So A is like a key. So these are the types of functional dependencies. Don't forget, we aim for full functional dependency. And in the next video, I'm going to show how you can actually find different functional dependencies. And see you in the next video.